All right, so first, you must know that the exponential power, okay, exponential e to the power of x or anything to the power of x, right, is an aeroplane taking off. It looks like this. Okay, now you need to draw this and then 1. All right, so this is y equals to e to the power of x, and then you have 0 here. Okay, so now most of the time you need to know how to draw this. Okay, most of the time you need to know how to draw this. Now, don't have to memorize how does the graph look like. In fact, derive the graph from that. That is the easiest. So you see now 0, this is your x, and then this is your y. From this guy to this guy, okay, you see the negative is at the x. Okay, the negative is at the x. So this guy is a reflection. Okay, on the y-axis, means the y-axis is a mirror. Basically, it means all your positive x value becomes the negative, and all your negative x value becomes the positive. So it looks like this. Okay, so it looks like this. All right, once you understand the transformation of the graph, right, okay, it's easier for you to do. Okay, so this from e to the power x become e to the power negative x. It is a reflection on the y-axis, and this is called because the negative is to the x. Now, next one, from this graph to this graph, what's the difference? This is e to the power negative x. Then it becomes negative. Can you see the negative is in front of it? Okay, when you see a negative in front of the graph, okay, it means the graph is, okay, this is a reflection on x-axis. Okay, why? All the graph from the positive will become the negative. So it looks like this. Here, -1. Understand the difference, huh? So I write down here. First, you got y equals to e to the power x. Then it becomes y equals to e to the power negative x. When you change the x to the negative x, it's a flip reflected on the y-axis. Then, if you put a negative in front of your function, okay, this is reflect on y-axis, because the y-axis is your mirror. This guy to this guy, the reflection is on the x-axis. Okay, once you understand all this, then you will be able to do things easier. So this guy, you move up a steps. Okay, that means, okay, everything move up a, then I will have here, okay, and there's this thing called the asymptote. The red ones are all the things that you're supposed to draw. The asymptote is at a. So this is called y equals to big A, and this is your asymptote. All right, so from here to here, we translate, okay, by A units along the y-axis. Means move up lah, okay, you move up. Okay, and most of the time, okay, you will be doing either this or, so if now I give you this graph, y equals to a plus e to the power of negative kt. Okay, first thing first is, all right, you look at e to the power of negative something. E to the power of negative something, how does it look like? It is aeroplane going downwards. Okay, so this is the y equals to e to the power of negative kt. Okay, so if you add something upwards, the green one is with the a, then you'll become here, and then there's an asymptote. Okay, so this is y equals to big A. The green one would be the whole thing, y equals to a plus e to the power of negative kt. Okay, so once you understand how does e to the power of something looks like, that would be the same as a to the power of something. Basically, you can replace e by any numbers. Okay, however, there is a restriction. Okay, so if you still have your paper, I'm going to write to you two things. Okay, that is actually in your e-math. Let's say this is y equals to 3 bracket 2 to the power of x. How does it look like? It is an aeroplane taking off. However, many students will make this mistake by do not know what to label this as. All right. So because this is on the y-axis, when you're on the y-axis, you sub x equals to 0. Your y will be equals to 2 bracket 3 bracket 2 to the power 0. 2 to the power 0 is equals to 1. So this guy is 3. Okay, so as a rule of the thumb, if you got y equals to k a to the power of something, remember, never ever tell me the 3 can times it. That means this guy confirm cannot be equals to 6x. It's not equals to 6 to the power x. It will never ever be equals to. The 3 is left out there for a reason. Okay, so as a rule of the thumb, if you are drawing y equals to k a to the power x, this is more for your e-math. All right, then this k here is this intercept here. Okay, however, this aeroplane taking off can only happen if a is greater than 1. All right, so I want you to take note. If let's say the question asks you to draw y equals to, I'll just do a simple one, maybe let's say half to the power of x. Remember, you cannot draw any power graph when this guy is smaller than 1. Okay, you can draw, but you need to make sure he becomes greater than 1. So this half is 2 to the power of negative 1 with an x on the outside. Okay, so this guy will be 2 to the power of negative x. Then, you start to draw. Okay, so we know that 2 to the power x is an aeroplane taking off. When it comes to negative, you are making changes to the x value. All the positive x value become all the negative x value. So the correct graph for that would be Q. Okay, which is in fact what you want, half to the power of x. Okay, so this is more for your e-math. All right. Okay, this is more for your e-math. So be careful. Your base must be greater than 1. If your base is not greater than 1, please change it to greater than 1. Then you draw. Okay. Now after today, all right, I hope that you know all the shape of the graph and how does it transform. That means if you make changes to the x, what happened? It is reflected on the y-axis. Your y-axis is the mirror, and then it flip to the left. If you put a negative sign, you are flipping downwards, and downwards flipping upwards, etc. Okay, and then if you add an a, that means everybody move upwards by a units, or the other way around. If you minus by something, then everybody translate downwards. Okay, and the asymptote moves along. Actually, all these are asymptote. Look here, all this one, right? The x-axis is also an asymptote. Okay, all these are actually asymptotes. All right, so when you move up, the asymptote also have to move. Okay, asymptote is the value that the x or the y cannot be. Okay, no objection. I will move on to the next part. Next, to draw log x and ln x. Okay, again, when I was a student, I never really memorized log x and ln x. Okay, so my teacher teach me the significance. Okay, which I'm now going to teach you the significance. All right, now log is log base 10, right? Okay, so log is an inverse of indices. So for example, if I want to draw y equals to 10 to the power of x, how does it look like? It's an aeroplane taking off again and cutting here. Okay, what is here? This is 1. All right, so this guy is called y equals to log base 10. Sorry, this guy is equals to 10 to the power of x. Okay, what I want to tell you is the relationship between log and ln is it is a reflection. Y equals to x. Okay, write down. Y equals to log x is a reflection on y equals to x. Then from 10 to the power x. Okay, so if this y equals to x is a reflection, it means that okay, here will be 1. This blue guy is called y equals to log x. Okay, I want you to understand the relationship between 10 to the power of x and log to the power of x. Okay, so in the case of, all right, so understand the relationship already, all right. Then let's find out, okay? Let me ask you, ln is log base what? Is log base E. E is just a number. If you type E into your calculator, right? If you type E into your calculator, E is 2 point something. Okay? So basically, if I want to draw, okay, so let's say the blue one is E to the power of X. Okay, Y equals to E to the power of X. And then the red one is Y equals to 10 to the power of X. Which one will be steeper? Okay, so it goes like this. This Y will be Y equals to 10 to the power of X. Okay, this guy will be steeper. And then this guy will be more gentle. Okay, actually, must be very close to the axis. Okay, now but before this, right, it will be also very close, but it will be on top of him. Once it passes him, then it goes up. Why is it that the 10 power something is higher? It's because this EI is 2.7 something. Okay, so if I have 10 to the power something and 2.7 to the power something, 10 to the power something will increase faster. Okay, so, but this is not the graph that we want. We wanted to draw Y equals to ln X versus Y equals to log X, right? Yeah, so which one is closer to the axis? The red one. Okay, so this is Y equals to log base 10 X. All right. So the blue one would be, it will hit, they will always intersect here, which is 1. Okay, intersect here, which is 1. This guy is Y equals to ln X. All right. So if you want to memorize, can memorize, but okay, but there's a 1,000 other things you need to memorize. Okay, so if you are told to draw the log graph versus the ln graph, okay, use the indices power to draw first. That means for the first part, ask yourself which base give you you will take off higher. Okay, it will increase faster. The higher the base it is, okay, it will increase faster. All right. So when you reflect it, ln is E. Okay, log is base 10. All right. Then you just reflect it the other way. Log X will be closer to the Y-axis. Ln X will be further away from the X-axis. Sorry, log X will be closer to the X-axis. Ln X will be further away from the X-axis. Okay, so everything I try to derive from my power graph. Okay, and this last one, Y equals to log. It doesn't matter what's the base, so that's why I didn't write the base. Log anything X minus A. This is something I want you to know. Okay. So from here, you should know that, okay, this guy is Y equals to log X. There'll be 1 here because log 1 will give you 0. All right. And then you realize that this guy here is an asymptote. Okay. Because you cannot log 0. You use log 0, you will become undefined. So that's why X cannot be equals to 0. There's an asymptote here at X equals to 0. So this is an asymptote. Yeah. Okay. So if I want to draw Y equals to log X minus something, I will always let X minus A to be equals to 0 first. Then I know that X is equals to A. Okay. All right. So basically for Y equals to log X minus A, right? Your X cannot be equals to A because you cannot log 0. Cannot be equals to 0. Okay, which means if I want, all right, so I will draw the dotted line. Here is A. there. This guy is y equals to log x minus a. Okay, so be careful of whatever is inside the bracket. Safe to say, I give you another example. This is y, this is x. So if let's say I have y equals to log base 5, yeah, x plus 1. Okay, what is the first thing you do? Check inside the bracket. Okay, so with x plus 1 equals to 0, x equals to negative 1. All right. A bit of a mistake here, because let's assume a to be positive, right? Then in this case, right, a should be actually here. Then the dotted line should be here. Okay, and then it should go up here. Okay, look inside the bracket, x plus 1 equals to 0, x equals to negative 1, which means, okay, which means that there's an asymptote at x equals to negative 1. So negative 1 is here. Then now we just draw the line. Okay, another thing is, how do I know that it passes through here? 0. Very important. So you can you see a pattern here? What's the difference between this graph and y equals to log x? You are moving it backwards by 1 unit. Okay, so if you are plus 1 to the x, if you are adding on to the 1, right, you're actually moving it backwards by 1 unit. Okay, so when y equals to log x, it's supposed to cut at 1. So the original graph was like that. This is y equals to log base 5x. So when you move back by 1, this guy will cut the 0. Okay, another way is that because it's on the x-axis, you just let y equals to 0, you can also get. Okay, let's just do one more. So if let's say I have y equals to log base 2 x minus 4. Okay, first thing, always, so you can do your by the side, y equals to 0, you can let, okay, so x equals to 4. All right, which means that your x cannot be equals to 4. So there's an asymptote here at 4. All right, so how does the log graph look? The log graph will look like that. Okay, and then what is this y-intercept? You can let y equals to 0, log base 2, x minus 4 equals to 0. So x minus 4 is equals to 2 to the power of 0, which is 1. So x is equals to 5. So over here you get 5. Always remember to label your asymptote. Okay, always remember to label your asymptote. Okay, usually this kind of graph drawing for log, you will only come out during a prelim exam or end of secondary exam. You'll get something very hard that will be like this. Y equals to log base 3, 1 over x minus 2. Okay, so remember to apply your law of logarithm to this, which means that this guy is equals to log base 3, x minus 1, x minus 2 to the power of negative 1. Then the negative put in front, negative log base 3, x minus 2. Okay, now if we are going to draw this, you need not draw the graph correct in one shot. You can use the transformation to help you get. Okay, so let me show you how do I use the transformation to help you get. First, don't care about the negative sign. Think of how you're going to draw this. Okay, so when I draw this, I know that there's an asymptote at, so I let x minus 2 equals to 0, x equals to 2. I know that when x is equals to 2, there is an asymptote here. So I draw this. And then I write x equals to 2. Okay, so and then the basic curve of the graph looks like this. If this guy is x equals to 2, this would be 3. All right, but this graph is called y equals to log 3 x minus 2. All right, what do I want? I want the negative. So this guy negative is in front. If the negative is in front, it will be reflected downwards or reflected to the left. Okay, so ask yourself, if negative is in the front, it will be reflected downwards or reflected to the left. So when it's negative is in front, you're making changes to the y value. That means all the positive y value become the negative y value. All the negative y value become the positive y value. So it's reflected on the x-axis. That means reflected downwards if it's easier for you to remember. Okay, so the correct graph would look like, okay, this. So this guy is y equals to log base 3, 1 over x minus 2. Okay, so my point to you is that sometimes if you see a graph that is complicated, you need not draw the graph correctly at one shot. Use the transformation to help you get there. Okay, think of what is the most basic graph that you can draw first, then slowly transform your graph to get there. Okay, so in other words, so what are some of the graph I memorized? Of course, I memorized y equals to a to the power x. That is aeroplane taking off. Okay, then I use my transformation to get that. The other one, so y equals to log x. So y equals to a to the power x, aeroplane taking off. So y equals log x look like this. Okay, how do I remember this? I remember it like, you know, the flower dome. Okay, I remember it as like the flower dome in Gardens by the Bay. So this is how I remember this. Okay, it's sprout outwards like that. All right, because this is the axis. Okay, sprout outwards like that. So this is how I remember the shape of the graph. All right, and then use the shape of the graph to get whatever graph that you want. Okay.